This is Mr. Craig again. I want to speak on this video on the difference between electrolysis and a galvanic cell. I noticed that when we were reviewing for the AP exam that a couple students had some concerns about the difference between the two, and I thought I'd do a real quick summary on the differences between the two. In the first point, I have electrolysis versus galvanic cell. Now, regardless of whether it's a galvanic cell or an electrolysis reaction, this still applies where we have NOx red cat. So no matter if it's a spontaneous reaction or a non-spontaneous reaction, oxidation is going to take place at the anode, reduction will take place at the cathode. So that will not change. So don't get hung up on that for the difference between the two, because that is the same. First thing I want to talk about is the electrolysis. Electrolysis, and I've got some bullets here. The first thing that you need to realize is that an electrolysis reaction is a non-spontaneous reaction. If you look at the picture here on the right, you'll notice that I've got a battery, because that's going to help supply our electrons, and so there's no way that this reaction is going to take place on its own. So we have to force this reaction to take place by putting work into the system, so to speak, or by providing a source for the electrons. Also, another thing that you'll notice about an electrolysis reaction, it takes place within a single chamber, or one chamber. You'll notice again in the picture that I have both the cathode and the anode within the same beaker here on this simple apparatus. And I believe I had this apparatus set up for you in class where you could look at it. Excuse me. But both of the test tubes were in the same solution here, and you'll see a difference with the galvanic cell. The next thing is when you do a equation or a problem, a math problem with this, and you're solving for delta G for electrolysis reactions is always positive. And that goes back to the first statement up here, dealing with that the reaction is not spontaneous. So we would expect delta G to be positive. Therefore, when you're looking at your cell potential sheet, you want to make sure that you are getting a negative voltage here, and that's a bullet right here. So if you have a negative voltage, then yes, you have an electrolysis type reaction. If your reactions that are taking place on the anode and cathode provide a total negative voltage. As stated before, a power supply is needed for this to take place, and the nice thing is when you look at the question, it will say that there's a power supply provided. Now, it may not tell you how much power is being provided to the system itself, and you may have to do a calculation to find that out. Let's see here. The next bullet here is you will need a calculator for most of the calculations when you're working an electrolysis reaction. It's not as simple as the galvanic cells. And one of the last things is that you'll be working with the unit coulombs. And coulombs has a conversion of either being amp seconds or joules per volt. So when you're working these out, neither of these two conversions for coulombs are actually listed on your equation sheet. So this is something that you want to remember when working these out. Alright, so that's electrolysis. Looking at the galvanic cell, looking at the picture below here, you'll notice that these are the same thing, two galvanic cells here. The one distinction is they have two chambers. Each one of these sets has two chambers. The anode has its own chamber, the cathode has its own chamber, and there's a salt bridge or a porous disc. In other words, we need a flow of ions of some sort to be migrating from one chamber to the next whenever this reaction is taking place. Alright, the galvanic cell, again, this is a spontaneous reaction. So this will take place on its own. We don't have to do anything. We don't have to put any work into the system. This reaction will take place on its own and create electrons. As stated just a moment ago, there are two chambers in this reaction, one for the cathode and the other one for the anode. We do not put the cathode and the anode in the same chamber with a galvanic cell. Delta G is negative. Again, that tells us that the reaction is spontaneous, so that is something that we would expect. Because delta G is negative, we would expect to have a positive voltage. So whichever arrangement or situation, when we change the redox equation to an oxidation, whichever of those two will give us the most positive voltage is what we're looking for this reaction to be spontaneous. As noted earlier on here, no power supply is needed. The system will generate its own electrons because it is a spontaneous reaction. And the last thing that I want you to make sure that you're aware of, and this typically only takes place with galvanic cells, is standard conditions. Within each of these chambers, if we're working under standard conditions, you have a 1 molar concentration and the temperature is at 25 degrees. If those conditions change, then we want to look at our equation sheet to make sure that we make the correct adjustments. But if we're under standard conditions, the voltage is equal to the cell potential. And I hope this helps. What I would highly recommend, I think I erased the day that we had for the electrolysis and the galvanic cell, but you can definitely go back to topic 11 under electrochemistry and review those types of problems. I'm hoping that you'll see these types of questions on the AP exam this year.